Just like we came up with a model for motion and constant velocity, and we used equations from math in order to make predictions with that model, we want to do that for situations where objects are accelerating. So we need to take some data and see if any sort of model fits this type of motion. The data we're going to collect is pretty simple. We're going to take one of these Angry Bird stuffed animals, we're going to give it a little toss, and let it fall. Now that doesn't seem like a lot, but there was something going on here. We know it fell because of gravity, which is a pull. This type of pull, it turns out, can be a good model for many other types of pulls. So how that bird's speed changed and its velocity changed throughout the flight will be interesting to us. What happens to the speed? Does it increase constantly, or does it increase more each time or less each time? Is there any sort of pattern? Is there any similarities between objects? So in order to start finding this out, we're going to use a technique called video analysis. I'm talking at my phone right now, which is sitting on the shelf of a locker directly across from me. And I picked that because it's really important to have a stable place for a camera to be. The camera is going to be looking at moving objects, namely this Angry Bird, as I throw it up and down. It goes up, it slows down, it stops, it comes back down. You know gravity was pulling it down, but that caused a change in motion. We had our initial velocity lost, it decreased, and then a new velocity in the opposite direction was gained. Here it is again in slow motion, where I think the different speeds at different parts of the motion become obvious. We can use videos to study motion because of the way that video files are made. They're actually nothing more than a set of still images that are shown sequentially. I think the easiest way to demonstrate this is with something I hope you made as a kid, something called a flip book. Let's take a look at one. This is obviously nothing more than a very simple drawing where I've moved the ball from position to position between pieces of paper. But our eyes see it as motion. We see it as a movie. It turns out that the video files your phone produces are nothing more than this. And because in each picture that the phone takes as it makes a video, the object is in a different place, we can then use this to study that object's motion. We can actually do exactly the same thing to study the motion of the Angry Bird. This software called Tracker enables us to step frame by frame through this motion and see where the object is at different times. Using the position data generated from this video, we can then study the motion. So the equipment we have to do video analysis consists of these laptops. And the webcam is actually going to be what's going to take our videos. So the webcam on these laptops is right over the monitor. And in order for the data to be any good, that camera has to be looking straight at us. There can't be any angles involved. So when you stand, you're going to be pretty far away from the webcam, but you want to stand right in front of it. And equally important, you want to have the monitor straight up and down, so there's no sort of angle or bending to the monitor. That's going to enable the video to have some meaning. Let's look at what you should do when you're standing. The camera is going to be looking at moving objects, namely this Angry Bird, as I throw it up and down. And if there was any motion on the camera, we'd have trouble identifying whether it's the bird that's moving or the camera. So you have to find a nice stable place to do it. The camera itself is actually going to do all the timing for us, because as the video file is encoded, it encodes how many seconds there are between each frame in the video. So the only thing we have to really worry about is making sure that the video contains accurate distance information. So there's a couple things that we do to achieve this. One is I'm standing directly across from the camera. There's no sort of horizontal difference between me and the camera. Because if I was at an angle, the camera wouldn't be able to tell that. It would add measurement error.
In addition, the camera doesn't know how far away I am, and it doesn't know how big I am. So what I need to do is put some sort of scale in the video. That's what this meter stick is. You can imagine that there's a plane that bisects me through my head like this, and all of the motion has to be in that plane for the scale to be accurate. Anything closer would be inaccurate, anything farther away would be inaccurate.
The most obvious way to see what I'm talking about there is to look at this ceiling tile. This is a square, but look what it looks like on this video screen. It looks like this edge is much longer than that edge. And that's just because of the way the camera lens records stuff. It distorts things. So it's really only for one distance from the camera that our distance data is valid. You can see here how the meter stick ends up being part of the file. We can tell Tracker exactly how long that meter stick is, and then everything that's that exact distance away gets scaled appropriately.
So now that I've explained this to you, the only thing I need to do is hold up my scale, and I'll move it around so that I can make sure it's on camera. I've got my Angry Bird in that same plane, and now all I have to do is give it a toss. And this is going to collect a huge number of data points in the short time that it's actually in the air. And that's it. Now we get to analyze the data.
So when you get to one of our laptops, you're going to go to the Start menu. You're going to go to V for Vernier, which is the company that makes this software, and you're going to choose Logger Pro. I've already got it open because it takes a little while to load. You're then going to go to Insert, and we're going to do Video Capture. And basically now the computer itself is going to take the video that we need in order to do the lab. So the next set of things will be a screencast of how to take the file that the computer generates and turn it into data points we can use.
So after you finish capturing your video, it'll show up just kind of randomly on top of Logger Pro. And you want to click the thing that looks like a series of dots in a parabola. That's actually the video analysis option. So a good chunk of your video is actually going to be useless because it's going to be you getting in position, getting set up, moving around to the camera. You want to basically scroll in the video, and you can step using these buttons until you get to the frame where the Angry Bird has just left your hand and your hand and it are separately visible for the first time. Notice I'm standing right in the middle looking at the camera. I'm fairly far away from it, and my meter stick is very clearly at the same distance from the camera as the bird. So all of that is going to enable us to get good distance data. So clicking the scale button brings up this dialog box. The first thing you do is you click and drag over your meter stick, and Logger Pro is going to assume that the thing you're using for a scale is 1 meter. That's a common thing to do. If you're using something else, even if you forgot to do a scale and you wanted to measure the length of your wrist or maybe the length of a tie or something, you could put in any distance you want. It's very important that the thing you're using as the scale, though, be the same distance from the camera as the thing that's moving. A step that's subtly important is to specify your axes in your reference frame. The reason this matters is that the force we're studying here, gravity, is a downward force. It's not a left-right force. And therefore the computer really needs to think of one of the axes, either as X or Y, as being straight up and down. So what you do is you click this button here, and you grab the origin of the axes, and you drag it to something you know is horizontal or vertical. I'm using the lab bench behind me. So I dragged it over here, and then you click this dot on the x-axis, and you could pinwheel it up and down. You just want to make sure your x-axis, in this case, is exactly parallel to something you know is horizontal. Once that's all set, you can click your origin again and move the axes so that your original position of the Angry Bird is at 0, 0. So it's probably worth talking about letters at this point. It's probably been frustrating to you up till now that we've not used D for distance. The reason we don't is that as things move in real life, they actually move in 3 dimensions. And in this video, we capture 2 of them pretty well. So motion that's up, down is along the y-axis or the y dimension. Motion that's left, right is along the x-axis or x dimension. We're going to see we have to treat both of those separately later. So that's why we're using x for distance up till now, because all the things we studied up till now have been moving back and forth. In this lab, we're going to use y for distance because the thing we have is moving up and down. Now that we've specified our reference frame and our scale, we're ready to start tracking. You click this crosshairs button, and then you go right to where your object is, and you click right in the middle, like you were tagging a photo. And what's going to happen is it's going to make a dot, and the film is going to advance by 1 frame. And then you just keep doing it. And what you'll see is the track your object's taking will start to be laid out on the screen. You're also going to see data points filled into this table. You're going to see this graph start to build itself too. So this is actually taking our video file and setting up numbers that we can then fit equations to later. This is what's going to help us build the model for motion of an object that's being pulled on by a force. So you basically keep doing this until your object essentially leaves the screen at the bottom. It may leave the screen at the top if you threw it too high. In that case, you can step forward until you see it again and then resume tagging. You'll have a gap in your data, but it'll be fine. So here's my completed data set of the Angry Bird, and you can see the graph has been totally filled in, and you may start seeing some patterns in the shape of that graph. Logger Pro can analyze data itself, but given our shortage of computers with Logger Pro that we're using in the classroom, we're going to export the data, and we'll use spreadsheets on other computers to do the analysis. You go to File, and you go to Export As, and the one you want is CSV, which stands for comma separated value. This is a file that every spreadsheet can read. Okay, so now you have a complete set of distance and time data for an object being accelerated by gravity. We'll analyze it in a different lesson, probably on a different day, and I'll go through that at that time. One thing about video analysis is it's pretty easy to do, and in some classes you will have labs where you kind of get to choose the technique and how you want to measure. The software we used here, Logger Pro, is commercial software you need a license for. We have it on our school computers. But you probably noticed there was another program I used earlier in the video called Tracker, which is a free and open source program that does very similar things and works almost identically for video. So I will have links up on how you can download Tracker if you want. It works on Linux, Windows, and Mac. You can have it on your own computer, and it's kind of fun to play with.